Hello everyone, I'm Shaun Spalding, and in this two-part tutorial I'm going to be walking you through building a simple platformer in GameMaker Studio 2. In part 1 I'm going to show you how to create a simple framework for a platform game, tackling those tricky beginner topics like collisions and gravity. And in part 2 we're going to dress it up with some fanciful artwork and pretty animation. So here we are looking at a blank project. This is a GML project, so when you hit new project, make sure you selected the GameMaker Language as the default action type for your project. So the first thing we want to do is bring in a couple of sprites, one to represent our player and one to represent the walls and floors that we're going to be walking on. So I'm going to go into sprites and hit right click and hit create sprite from images. This will just bring up a file explorer, so we can just find an image and bring it straight in as a sprite. Where you will access these depends on where you're watching this video. If you're watching the tutorial in the IDE, then there'll be a link in there for you to get these assets. If you're watching on YouTube, it'll be in the video description, or if you're on YoGame's website, it'll be in the blog post. I just have all of these images in a folder on my desktop, so it's for easy access. I'm going to bring in this one here called S player, okay? The small s standing for sprite, and player obviously being player. Bring that in, and this is our player sprite. Okay, I'm gonna, where it says origin here, rather than, I could set this manually if I want, just by clicking around. This determines kind of the center point of the sprite. I'm gonna click this drop down list here though and select middle center, which will just automatically calculate the coordinates needed to be exactly in the middle of the image, and that will do us just fine. Make sure you name this sprite. I'm going to call it S player. It doesn't matter what your naming convention is for your sprites and objects as long as it's consistent. I name mine via a single lowercase letter representing what type of resource it is, and then just a helpful capitalized name afterwards that tells me what that thing is. So this is a sprite, so small letter S, and it's the player, so capital P, player. Okay. I'm going to bring in another sprite, so again hit create sprite from images, and I'm just going to select S invisible wall here. Okay, and you see it just brings in this red box with some transparency in it. These walls are not actually going to show up in the game, but they're going to be used by us in our platform just to mark out areas where we want to be able to walk, and we'll put the artwork of the level itself on top of them later. Okay, so I'm just going to call this one S invisible wall, as it was named in the image. If you want to, you can also reposition the origin on this sprite. I just leave this one in the top left. It doesn't matter too much for the invisible wall where that origin goes. Once you've brought in these two sprites, that's all we're going to do with sprites and artwork for this part. We'll be focusing on all the fancy animations and stuff like that and getting them set up in part 2. We just need the basics in so that we can represent our player and the game world in a very simple way. So go ahead and close those once they're both brought in. The next thing we want to do is create two objects. Again, one for the player and one for the wall, the two sprites we just brought in. So go ahead and right click in objects and hit create object. And we're going to name this first one O player. So again, O for object and player for player. We're going to assign a sprite to the object, and that sprite is going to be that player sprite that we just brought in. Now, before we get started on any of the logic for that player, let's go ahead quickly and make the object for the wall. So again, make another object, right click object, hit create object, or even press Alt O if you want. We're going to call this one O wall. And select the sprite S invisible wall. If we now come through to room 0 under rooms, this default room will be created for you every time you make a new project in GameMaker. If I double click that, it'll bring us to the room editor. So this creates all of our levels and screens in the game, and we already have a couple of layers set up for us, instances and backgrounds. So let's just dress up the room a little bit so we know what to expect from our game. So with O wall selected and also the instances layer selected, I can hover my mouse over the room and hold the Alt key, and you can see the wall will appear under my cursor. And I'm just going to place a handful of these around the room. What I can also do is just sort of stretch them. They're going to be invisible walls anyway, so it doesn't matter if they're kind of like stretched out a bit, just to kind of create a hypothetical little platform level. Okay, we'll just create like a little jump that you have to do, something like that. And then we'll also bring in our player object in the same way. So click on player, hold Alt, and we'll pop him over here. Now we can't really see a lot of our player sprite that's in black against a black background, so just temporarily I'm going to go to background, the layer here, and show you how you can just change the color. So you can see here where our color is black on this background layer. I can just click that color and just, I don't know, we will just change that to some sort of nice light teal or something, just so we can see what's going on. There we go, and now we can see the player. Now, we've written no logic for this game, but we've placed some things in the game world. So if we run our game at the moment, we'll just end up with a window that shows, well, exactly this, okay? So there you have it. There's our game. It doesn't do anything yet. We've got a character, we've got some walls down here, but it can't move around or do anything. So that's what we're going to set up next. So I'm going to double click on OPlayer to bring us back to our player object. I can fold away this room editor tab now as well, so we don't really need that right now. And I'm going to go to add event and hit the create event. And in case you're very new to GameMaker, remember that this is fundamentally the key to how GameMaker projects work. Okay, you have events and then you have actions over here. Events are when a certain thing happens, and then actions are carry this out as a result. Okay, so when this object is created, do these things. And what we want to do in the create event for our player is establish some key variables. And if I write this in the code here, and let me just make this nice and big so we can see. In fact, we'll full screen this. If you write 2 slashes, you can write this green text that is just a comment that isn't processed code at all. And if you write 3 slashes and an @ symbol and desk at the very start of a block of code, and write something in there, when you look at it from the object editor, you can see that description has come up next to our event here. So create, establish some key variables. It sort of labels it for you, so that's quite handy. Now all we're going to do is establish some key variables. I'm going to create the variable HSP, which is going to represent our player's horizontal speed, set to 0, VSP for vertical speed, GRV, which is going to be our gravity. Okay, it's important to use that, by the way, and not gravity, all one word, because that's a built-in function of GameMaker. We're going to handle gravity ourselves in this tutorial. So GRV equals 0.3. I'm going to accelerate at 0.3 pixels a frame downwards. Walk SP, which is going to be our walking speed, so how many pixels a frame we move left and right when we press the right key. And jump SP, how quickly we can jump, which is going to be, say, 9 pixels a frame when we press the jump key. It's going to be a nice big number, so we get a big initial jump. And now as you type these, you'll get these little warning symbols coming up next to it. If you hover over it, it'll say variable HSP only referenced once, and that's just to help us out later on in code if we were we'd run a bunch of code and we'd made a variable somewhere that we'd never actually used. It's there to warn us that we've got a pointless variable, essentially. Of course, they all say that at the moment because we've only just established them, and they're only referenced in this one place and they're never used anywhere else. That's fine. Those will go away once we've done some more code. Okay, so now that I have these key variables in place, we can go ahead and start working on the main game logic for the player. That's going to be in a different event though. So this is the create event, as I said, just when an instance of the player gets made for the first time in the room. We set these up and then we don't do it again. I'm going to come back to the player object and add the step event. Okay, that's in step and step, not begin or end step, just a regular step. The step events are a particularly special event. It's the only event that kind of happens by itself. All right, the step event will happen every single game step, which how many of those there are and how fast they are depends on the frame rate of your game. If you go to game options, you'll find that by default your project is set to 60 game frames per second. I recommend leaving it at that. And that means anything we do in a step event, for an instance, will try and carry itself out 60 times a second. Okay, so it can be very dangerous to put some things in here that you'll end up, doing things 60 times a second you don't want to. But it's also a very, very useful place for creating the bulk of our game logic, so things that we want to check regularly, like checking whether or not we're pressing keys, whether we're colliding with things, physics, and so on. All right, very, very useful event. So you might be wondering as well how I get this to automatically appear in my code editor. Okay, this labeling thing for my event. If you go to File and Preferences and go down to Object Editor, you'll find default event content. I can't remember what it says by default in GameMaker Studio 2. I think it says something like you can add your own code to this editor. I changed it to be the 3 slashes and @desk that you need in order to create a label for the event, because that's the most useful thing I find to have automatically in an event. You can turn it off entirely, just untick this, add default event content, and then you'll just get a blank code editor every time if you want. But I find it useful to have this, so I can quickly label my events. This one I'm going to label core player logic, as that's basically what's going to happen in here. We're going to do all of our inputs, physics, gravity, and so on. Okay, we're going to do all of that in here. I'm going to maximize this now, because this is basically where we're going to be working until more or less the end of the tutorial. So the first thing I want to do in here is get our player's inputs. Okay, so that's reading which keys on the keyboard our player is currently pressing that are important to us and react appropriately. So I'm going to type another 2 slashes for another green comment and just write get player inputs, just to remind ourselves as the programmer what we're actually trying to do in this next section. Okay, it's useful for that. Now we're going to keep things simple in this tutorial and only check just the arrow keys, the left and right arrow keys, and our space bar, right? So move left and right and jump, that's all we really need to do. The way we do that is by creating a couple of variables that are updated every frame with whether or not we have pressed a certain key. Okay, so I'm going to type key underscore left equals, okay, just creating another variable, and this variable is going to be updated again in the step event, so every single frame, with keyboard underscore check open brackets vk left. So keyboard check is the function that checks a certain key, and we provide vk left, which I think is virtual keyboard left or something like that, which checks our keyboard to see if this specific key is being pressed, and that represents our left arrow key. Okay, and if it is being pressed, key left will equal true, and if it's not, key left will equal false. Okay, and that'll be useful to us later on. Then I'm going to write key underscore right equals keyboard underscore check underscore, and then open brackets vk underscore right close bracket semicolon, which does the same thing with the right arrow key, and then key underscore jump equals keyboard check pressed this time vk underscore space. So I've written a slightly different function for this one. Keyboard check, as I said, tells us whether or not left is currently being pressed, or the right arrow key is currently being pressed or not. This checks to see whether or not this key has just been pressed this frame. Okay, so if you're holding it down and the spacebar is down, but it was also down on the previous step, then it will return false. But if you pressed it just on this frame, so you've pressed spacebar and on the previous frame spacebar wasn't pressed, then it'll return true. Okay, it's very handy. So it just tells us, so it's so that we don't keep like repeatedly jumping just by holding the spacebar. Okay, we have to specifically press the spacebar in order to jump. Okay, it's just useful to demonstrate that. Okay, so now every game step we have calculated whether or not we're pressing left, right, or the spacebar. So now what are we going to do with that? Well, we are going to calculate our movement, okay, based on whether or not we're pressing those different keys. So I'm going to create a new variable. I'm going to create it in a slightly different way. I'm going to type a var, and then I'm going to create the variable underscore move. Okay, when you create a variable using var, you can see this turns like a yellowy color. It means this variable is script local. Okay, so it means once this step event, once this whole script is carried out, we ditch that variable because we don't need it anymore. It's just removed from memory at the end of the script, okay? It can be very, very useful for variables that you don't need to hang on to, okay? So you don't want to have them hanging around in memory. There's other different kinds of uses as well, which you'll discover as you learn more about GameMaker. But for now, that's all you need to know. Move is going to store whether or not we want to move left or right on this particular step. That's why we don't really want to hold on to it as a variable, okay? So I've established it as a temporary variable, or a local variable as it's technically called, using VAR. If you're also wondering why I put an underscore at the start, that's just my naming convention for any VAR variables, any temporary variables, just to distinguish them from my other variables. I always tend to put this little underscore at the start, okay? So underscore move is going to equal key right minus key left. Now this might be a little tricky to get your head around, but it's a simple trick for working out which way we want to move based on these keys and boiling it down to one variable. What I want to do basically is end up with either 1 in move if I'm moving to the right, or -1 in move if I'm moving to the left. How do I do that? Because I said we get true and false in these two variables, right? Well, that's true, but true and false, the way they work in GameMaker, is they're also equivalent to 1 and 0, okay, and how it works in a lot of programming. So if something is true, it is also 1, and if something is false, then it is 0. So think about this. If we are holding the right arrow key and we're not holding the left arrow key, that would be 1 minus 0. So it would give us 1, so we're moving to the right. If we're holding left and we're not holding right, that would be 0 minus 1, giving us -1, allowing us to move to the left. If we are holding both keys down, that would be 1 minus 1, which would give us 0, so we don't move in either direction, okay? So they kind of cancel each other out in that regard. And if we're holding neither of them, 0 minus 0, same thing, okay? The reason we want it to be 1 if we're moving right and -1 if we're moving left is because of how coordinates work in GameMaker. So the further to the right we are in our room, you can see if you look in the bottom left corner of the room editor, our X coordinate, it moves up as you move further to the right, okay? So by increasing our X coordinate, we're going to move to the right. And by decreasing it, we're going to move to the left, okay? And for Y, if we increase it, we go down. If we decrease it, we go up, which will be important in a little bit. So just come back here to our game logic. So that is very simply just boiled down our left and right arrow keys to whether or not we want to move left or right on this frame. Very useful. So we're going to take HSP, that variable that we declared earlier to represent our current horizontal speed, to equal underscore move multiplied by walk SP, which is our walking speed, which you'll remember we set to 4. Okay, so if we're moving to the right, we'll have 1 times 4, so we'll move 4 pixels to the right, and if we're moving left, we'll have -1 times 4, we'll get -4 moving to the left. Now I can quickly just demonstrate this working if I just write x equals x plus HSP. Okay, so x is going to equal itself plus HSP, or plus our current horizontal speed. If I then run the game with our player currently in the room, I should be able to press left and right and move left and right. So here's our game, and if I press left and right, we move left and right. So that's working. We don't have any gravity yet, we don't have collisions yet, but we've got our first basic piece of game logic in. Okay, so now you've seen how it works. We're going to get rid of that line for now. We'll bring it back in later when we've done some other stuff. I'm going to put our vertical speed into place. Okay, so that's similar to how we did horizontal speed, but a little bit different. Because we're not controlling our vertical speed, we're kind of leaving that up to gravity. So we're going to write VSP. Each frame is going to equal itself plus GRV, which is that gravity value we set to like 0.3 if you remember. So every single frame, VSP is going to increase initially at 0, then to 0.3, then to 0.6, 0.9, 1.2, etc. Okay, so you will get faster and faster moving down. That's how we accelerate. Okay, in fact, we can then demonstrate that again if I put x equals x plus HSP back in and y equals y plus VSP. we should see, I won't be able to move left and right for very long when this runs, because I'll just fall straight through the floor, but you'll see we fall from our starting position now. So you see, there we are, and I moved a tiny bit at the end right, but you can see how we fall now, thanks to gravity. So the main thing for us to do next is to implement some collisions, okay? So I'm going to get rid of both these lines again. We'll put them back. First of all, we're going to work out our horizontal collision. Okay, vertical and horizontal collision are worked out in pretty much the same way, but we have to kind of do them separately. So this is the tricky part for most people when they're working on their first platform game. They can generally work out this kind of stuff and move their character around the screen. They struggle when it comes to collisions, and that's because traditionally when you create, say, a collision event in a particular object, you're checking to see if that object overlaps with another object, okay? So if its position overlaps with another one. But the thing is, by that point when your player's hitbox is colliding with a wall object, you're kind of too late. What you really want to do in your game logic is prevent that collision from happening in the first place. So you're not really looking for whether or not a collision is happening, you're looking for whether or not a collision is about to happen, and then you want to move as close as you can to that wall without actually going into the wall on a given frame, okay? Because we want to walk on top of the walls, we don't want to walk like in them, right? That's the sort of anti-intuitive part of doing collisions in a platform game. It's what makes people kind of struggle with them a little bit, but once you understand it, it's not too bad. So how our horizontal collisions work are, we're going to type if, okay, open bracket, place underscore meeting, open bracket, x plus hsp, comma, y, comma, o wall, close bracket, and this here, I put o wall, but whatever you've named your wall object, you can put in there, okay? So if obviously just says, you know, whether or not this statement is true, carry out the things below it. A place meeting will essentially place, you can think of it as placing a virtual copy of this instance's hitbox, so our player's hitbox, at these coordinates, and seeing if at those coordinates a copy of our hitbox would overlap or collide with this object. Okay, that's the easiest way to think of it. And if it does, then it returns true, and if it doesn't, then it returns false. So what we're doing here is, before we actually move via our horizontal speed, we're checking to see if the position we would move to via our horizontal speed contains a wall. And if it does, we need to do something about that. So come under here and open up curly braces for our if statement. And what we're going to do is then type while. What a while statement does, it's sort of similar to an if statement in that it, you know, we declare a condition, and if that condition is true, we carry out what's in the brackets. But the difference between a while and an if is that a while statement will keep running the stuff in its brackets over and over and over again until the whatever statement you put in front of the while is no longer true. So you have to be very careful with while statements and make sure they do actually end up becoming false. Otherwise, you get an infinite loop and your game will just freeze and crash, and that's no good at all. So what we're going to do is check while there is no collision, like 1 pixel in the direction that we're trying to move. We're going to move 1 pixel towards the wall, okay? So we're going to try and move as close as possible by moving 1 pixel at a time towards the wall. So by putting an exclamation mark, that will inverse our condition. It basically means not, all right? So while not, place underscore meeting, open brackets, x plus sign hsp, and I'll explain that in a second, comma y, comma o wall, close bracket, close bracket. Okay, so again, we're checking for a potential collision at a particular set of coordinates. This time at x plus sign hsp. What that does is sign returns a 1 0 or -1, depending on whether or not the value you give it is positive or negative. So if we're moving to the right, this will be like 4 or whatever, right? So sine HSP will return 1. If we're moving -4, it'll give us -1. Basically brings us back to where we were before, right? So either x plus 1 or x minus 1, depending which way we're going. We're going to check that position for a wall and then inverse the result, okay? So if there is a wall at this position, it'll return false, and if there isn't one, it'll return true. So while there isn't a collision, 1 pixel in the direction we're moving, carry out what's in here. And what we're going to do is just move ourselves 1 pixel in whichever direction we were traveling by doing x equals x plus sine HSP. Okay, so we just move 1 pixel either to the right or 1 pixel to the left by either adding 1 or -1. And just keep doing that until 1 pixel in the direction we're moving, there's going to be a wall. And we know that will happen because we've already detected that there's going to be a wall somewhere in the 4 pixels that we're trying to move, right? Once we've done that, we're going to set HSP to be 0 because, you know, we've hit a wall. And then that's our horizontal collision done. So once we've done this check and set HSP to 0 if we need to, we can commit to our horizontal movement. So I can do x equals x plus HSP. All right, and that's how horizontal collision works. And basically how vertical collision works is exactly the same. So I'm just going to copy this whole chunk of code. Underneath, I'm going to paste it, change horizontal to vertical, remove plus HSP from here, and write plus VSP here. Very, very easy to accidentally write HSP or VSP or put them in the wrong place. So make sure you're doing this very carefully. Just follow exactly what I'm doing. So I removed plus HSP there and put plus VSP there. Just double check it against my code if you want. And then in this while statement, we're going to remove this plus sign HSP. And instead, next to the Y, write plus sign VSP. Change these X's to Y's, change HSP to VSP in both these two places. And here we change Y to equal Y plus VSP. It's exactly the same logic, just going up and down rather than left to right. Okay, exactly the same. And that is everything to do with our main collisions and committing to our movement. So if I run the game now, you should see that we land on top of that wall cleanly, and we're able to move left and right on top of it. So you see I've landed on the wall and I can move left and right. Okay, so we still need to add our jump in, but if I fall off the edge of here, you can see like the gravity brings me down and I fall and I land correctly. Okay, now the reason we had to do all of this in the first place is we can't just set our speed to be 0. If we just set our speed to be 0, we'll stop too early, right? If we're 4 pixels away from the wall, and we're about to move into the wall and we just set our speed to be 0, that's all well and good, we won't collide with the wall, but we will also leave a gap between ourselves and the wall. So that's why we do this, to move ourselves as close as possible so that we actually land flush against the wall. All right. So if I just scroll back up here to where our vertical speed was first calculated with our gravity, underneath that I'm going to write a check to allow us to jump. Okay, so if, open bracket, place underscore meeting again, x, y plus 1, comma, o wall, close bracket, close bracket. Okay, so you should be fairly familiar with how this works by now. We're checking these coordinates to see if there's a collision with this object. Okay, so 1 pixel below where we're currently standing, there is a wall. So we're standing on a floor. Then what I'm going to do is I'm going to write 2 ampersand symbols, which represents sort of a logical and. You can also write and if you want. Just do one or the other. I'm just going to do my double ampersand because that's what I'm used to. Open bracket, key underscore jump. Okay, so what this has done, instead of doing if this one statement is true, is I'm checking to see if both these statements are true. Okay, if this and this are both true. Okay, open a couple curly braces like that. And what I'm doing here is checking if 1 pixel below us is a wall and if key jump is true, okay? And we know that key jump will be true if we press the spacebar, okay? Then all I'm going to do is type VSP equals negative jump SP. Remember, jump SP is like 9, and remember that in order to move upwards, we need to reduce our Y coordinate, so this needs to be negative. So we set our vertical speed, whatever it currently was in the past because of gravity, or because of colliding with a floor, or whatever. Whatever it was, we just set it immediately to -9, and then we'll fly up into the air. But every single frame, it'll be increased by gravity to bring us back down. Okay, so we'll come back down, and that's everything. That if I just sort of shrink that down to get it all on one screen there, that is all of our players' logic for a very simple platform framework. So if I press F5 now and run the game, you'll see we can do all of that stuff. We can run around, we can jump, and we can land on walls and run into walls. Okay, so here I am. Left, right, spacebar makes us jump. We can jump down here, jump back up here. It's a little bit tight, but we can just about make it. And there we have it. So there's the framework for our platform game. In the next part of the tutorial series, we're going to be bringing in some animation and stuff. So we make this player animate when they run left and right, jump and fall and so on. And we'll be dressing up this environment to make it look a little bit prettier than it currently does. Okay, thank you very much for watching. Hope you learned a lot from this, and I'll catch you guys next time.